a long lecture, so it's about 1.5 GBs being uploaded. Today's lecture will also go, inshallah, up today itself. Lecture slides, as I said, from next week will start going up before the lecture, I hope. There might be some slight changes during the lecture, but overall there will be the same slides. There are no labs next week. There are tutorials, and the way tutorials are done is they will be live, like the lab, okay, and they will be optional to a certain degree. So we will be taking attendance, but it's slightly different than the normal tutorials you might be used to. What will happen is, at the beginning of the tutorial, the instructor will solve some questions, so maybe some from the back of the book, some of the homework problems, not all of them, but some of them which we find interesting, or which we think, you know, there is something tricky about them, or something that you should be paying attention to. And after that, we will open the floor to a question and answer session, where if you are having problems with your homework problems, if you are having problems with solving book examples, etc., you get to ask the instructor for help, for specific help with the questions, and they get to answer you. Now, of course, the instructor does not know the answers to all questions off by heart. So there will be cases where they will take some time, where they will tell you to wait until they try to do it on a piece of paper and then get back to you. But it will be a largely interactive session. Now, there is a quiz associated with these tutorials, but the way we're doing them is, since there are many subsections, okay, is that we're going to be doing it for all sections at the same time. Now, I'll be sending an email later today about this, but basically the way it's going to be done is, it's going to be a very, very short quiz, say no more than 10 questions, no less than 5 questions, mostly 5 to 7 questions. Very simple, out of 10 marks. Someone has their microphone on. Could you mute that, please? Thank you very much. Okay, and it will be a live quiz in that everyone does it at the same time, and you will also get your marks immediately. Okay, so as soon as you finish the quiz, we will be doing it so that you get your marks immediately. It will mostly be multiple choice, maybe some very simple numericals, but mostly multiple choice. And it will be held at a time when all 4 sections are free. 11, 12, 21, and 22. We're still trying to figure when that is, but most probably it will be on a Thursday. It will be once every 2 weeks, and it will not take more than 10 minutes. Okay, so I know this is outside of scheduled tutorial hours, but it's simpler for you and for us if we do it this way, because online is much, much more difficult than when we do it face-to-face. Okay, I'll be sending the timing. Okay, we need to make sure that no one has anything at that time. It might be in the evening, okay, so that we're sure everyone is available. You can do it also on your phone through the Moodle app, okay, for 10 minutes. So it's not an issue. Yes, of course, the marks will be recorded. It is a quiz. And I said no more than 10 minutes or 15 minutes maximum. Okay, so it's going to be rather short.
دكتور
أيوة.
بيكون تاريخ 30.
لا، أغلب الظن بيكون تاريخ واحد اللي هو يكون يوم الخميس، بحيث أنه كل السكاشن تكون أخذت التوتوريال وخلصت.
انه بيكون تاريخ 30 اذا كان الخميس.
لا، الخميس يكون
بيكون
تاريخ
اربعاء. بيكون اربعاء.
30 أربعاء، 1/10 يكون الخميس.
اوكي
تمام. Some of you have asked, have emailed me saying they are scheduled to come pick up their books on Sunday. Some are scheduled to pick up their books on Tuesday. So you don't have to worry about missing the quiz. But the tutorials are a very integral part, okay? I try to do as many examples as possible during the lecture, but the lecture time is very, very limited. So there are only, and we need to finish actually 14 chapters in this course. So the tutorial is where most of the examples are done and where most of this cut work is done. Okay, it will include chapters 1 and chapter 2. Okay. I literally answered these questions now. How long will it take? When will it be? What will it include? Okay. Chapters 1 and 2, Thursday. I'll confirm the time by email, but it will be at a time when no one has any other things to do. So most probably, let's say around 5 o'clock, when we're sure that everyone is done with. Okay. Yes, it will be marked. It will be out of 10 marks. You have 7 tutorials during this semester, and the average of all the marks, okay, will be taken as out of 10 marks for the lab, for the tutorial. And the same will be done for the lab. No, it does not include the lab manual. Okay, lab is lab. This is tutorial. So lab and tutorial are two different things.
Doctor,
Okay.
excuse me, I'm late. Can
Yeah.
you explain again?
No, sorry, I cannot.
Okay.
Okay. So, moving on to our vector sessions. Okay. I'm trying to arrange everything. PI is also to go up by next week. It takes a lot of time because previously we were using Google Classroom, not Moodle. Okay, but this semester we are moving everything to Moodle because it's simpler for you to have all your courses in one place, and also it's hosted in SQ, so it's free for you to access. Okay, because Untitled and Uridu have agreed that anything that is an educational website is free to access. But that also means that this is triple the workload for us, because while we have everything ready in Google Classroom, we need to recode everything from scratch for Moodle. So it takes a bit of time until we manage to port everything from one platform to the other. Okay. All right. Some of you have asked about attendance. So far, I have not taken attendance for the lectures. From next week onwards, I will be starting to take attendance on the lectures, and it will be done via an electronic method, so by attendance in this thing. I'm still having some issues with guaranteeing attendance. So until I fix that, it is unfair for me to take attendance from anyone. Okay, attendance of tutorials is also taken. Attendance of labs is also taken. Attendance of tutorials is taken by the quiz. Attendance of labs is taken by the submission of the worksheet of Moodle. This is why many of you who have told me, who have emailed me their solution manuals, I have asked you to submit it directly into Moodle rather than emailing it to me. Okay, now that that is done, why is this not working? Enable grid view, for the love of God. Okay, let's see if I am able to make this work. I'm not sure, but I will try. Okay, so I'll share my screen now to continue our chapters. Is it presenting? Not working. Okay. Can you see my screen?
Yes. Yes.
Okay, perfect. Okay, excellent. Okay, so the last thing we spoke about in the previous lecture was components of vectors, and we said that while drawing vectors to scale and taking measurements, which is what a lot of people, for example, in the airline industry do, pilots or captains of boats and oil tankers, etc., do it this way on maps to scale. As physicists, that's not always really useful for us. Also, it's not the best mathematical way to do it on a piece of paper, that to draw them every single time. So another way to do it, we said, is to look at components of vectors. Let me try to open the chat window in my phone so that I can actually see what's going on at the same time. Google Meet. Okay. And okay, here we go. Now I can see your messages in real-ish time. Okay, so we said there is an alternative mathematical way of looking at this issue, which is by looking at components of a vector, and we define something called resolving the vector into its components. And what that is, we said, if we have an xy axis and we have a diagonal vector or something that is not exactly x or not exactly y, we said what we can do is we can look at the x components and the y components of it. So to go at an angle, you need to have both x, a little bit of x, and a little bit of y. So what we say is, okay, rather than just looking at it as, for example, 10 newtons at 30 degrees, for example, I am going to look at it instead in its original form, as in how much x and how much y. And we said this is called resolving into components. Now, how do we do this? Some of you already know from maybe from other courses or from reading in advance. Now, what happens is whenever something is at an angle and has both components of x and y, it will have some angle theta. And we can use trigonometry to resolve it into its components: sine, cosine, and tan. what do we do? Say we have some vector v, which is going at this angle theta. We want to know what is vy and what is vx. Now, the very well-known trigonometric components, the sine will be the y over hypotenuse. The cosine will be the x over the hypotenuse. I'm going to denote hypotenuse by h. And the tan will be y over x. So tan y over x is going to give me this angle theta. So if I reverse engineer it, I want to know what only x is. I take the entire vector v, and I multiply it by cosine of the angle, v cosine theta. And I get vx. What about y? I do the exact same thing, but with sine. So I only get the y component. Now, there's a very important point here. In this example, it is cosine and sine. I could draw this very same vector, but instead, this exact same vector v, but instead of giving you this angle, I can actually, I can actually give you this angle. What happens if I give you this angle? What changes?
We have two choices here.
Cosine, sine.
Exactly. The cosine and the sine flip. Okay. So whenever some students tend to memorize x is v cosine, y is v sine, and that's not always correct. So always look at the angle, mark which one is opposite, which one is adjacent, which one is hypotenuse, and do the cosines and sines accordingly. What about the magnitude? If I want to know what is the magnitude of v, say say instead of giving me the v as the resultant vector, someone tells me vx is this number, vy is this number. How do I find the resultant v? Well, we defined the magnitude before. All we do is we find the magnitude. So we take vx squared plus vy squared, and we take the square root of that. So this is actually not displaying properly. This is supposed to look like this. Okay. Now, what about the direction? Say someone tells me I have vx equals 2 meters, vy equals 4 meters, and what is the resultant vector v? Well, v is going to be 2 squared plus 4 squared, square rooted, and I'm making these numbers up so I don't actually know what it is. 4 squared is 16, and 2 squared is 4, so that's 20. So it's going to be square root of 20, 4.47, let's say about 4.5 meters. And the angle will be the tangent of vy over vx. So tan theta equals vy over vx, which tells me that theta equals, perfect, tan inverse of 4 over 2, which will be about 63.4 degrees. Perfect.
Doctor,
Yes?
always we use tan for find direction.
Yes. For the direction, it's always tan because it's defined as y, tan inverse of y over x.
If he not give us for tan, we can use cosine or sine.
It depends what are the components you have. So let me go to a whiteboard. I have way too many things open.
Yes.
Okay. So
Yes.
any vector at an angle v will have an x component and a y component, correct? Okay. Now it really depends on what is the information that you have. Your trigonometric identities are exactly still the same. You have sine equals opposite over hypotenuse, you have tan equals opposite over adjacent, and you have cosine equals adjacent over hypotenuse. Okay?
Yes.
So it depends what are the angles you have. You can use whatever you want. But most often, it will be very rare for you to have one information that requires you to use the cosine or sine for the angle. Say, for example,
Yes.
let's do an example. Say, for
Okay.
example, I'm trying to think of a case where you will need to use cosine or sine for an angle.
Yes.
It could be someone you might get a problem which tells you Vx equals 2 meters and theta equals 63 degrees. What is the vector? Well, I know that that V cosine theta is equal to Vx. So if I want to know what the total V is, I will do V equals Vx divided by cosine theta.
Yes.
Yeah. So you can use it. There is no reason why you shouldn't be able to use it.
Okay. Thank you.
Okay.
Yes.
Why am I unable to go back to my presentation? Okay, here we are. Okay. What is the analytical method of addition? Say we have a vector C, which is the resultant of A plus B. A shatah at some angle, B is at some other angle, and we want to find what the resultant C is. Now, one way we did in the previous lecture is draw these to scale and add them up to scale. So if this was to scale, I could actually use a ruler, put it here, and do this. If this was to scale, okay, this is not working. If this was to scale, I could do this and measure it with a ruler. But what if my drawing is not to scale? Okay. Or personally, what is the easiest way to me? Well, what I do is I find what are the components of A, AX, AY. I find what are the components of B, BX and BY, and I simply add them up. Okay. So CX will be equal to AX plus BX. CY will be AY plus BY. And then I find my magnitude by finding the magnitude of the CX squared plus CY squared square rooted. Now, this might sound to you a little bit complicated or a bit of a headache. Why should I do this when drawing is really nice? Well, drawing is really, really nice when you have one or two components. What if you have something like this, though? Let me show you. What if you have something like this? 1, 2, 3, 4, 5 vectors. A plus B plus C plus D plus E. Many times you will find that rather than doing all of these by hand, drawing them to scale, taking measurements, it's just easier to do the math on a piece of paper. Okay. Okay. Here's a quick PI to know if we have understood what we have said so far. The solid line has a length A and makes the angle theta with the negative y-axis as shown. What is the length of the dotted line? So what is the length of this line? Take a minute, try to do it. You have A cosine, A sine, A tan, sine theta over A, and cosine theta over A. Which one do you think is the correct one? I actually don't remember, so I'm going to be doing it with you on a piece of paper. Okay, I am done. Someone has responded saying a cosine theta, someone else says cosine, someone else says cosine. Correct. Perfect. It is, in fact, cosine theta. So what I did was, I simply drew what drawings I had. I said, this is my hypotenuse, this is my opposite, this is my adjacent. I know what this is. I know what the angle is. I need to find this. So what I'm doing is, cosine of my angle equals adjacent over hypotenuse, which is what I don't know, over A. So A cosine theta is equal to my unknown. Okay, simple enough? Good enough?
ليش ما بالسالب دكتور؟
ليش ما بالسالب ايش؟
ليه؟
Because I'm using the magnitude of A. A is just the magnitude. The
okay.
direction is given by the angle.
Okay, yes.
Okay?
Yes.
So actually if you realize انه في هذا الصورة، خليني امسح هذا الاشياء، الاتجاه مال A is not actually given. Yeah. I haven't actually told you if it's in this direction or if it's in this direction. So we cannot say if A is positive or negative. If A is in, it has decided to stop working now. Okay. If A is in this direction, it would be negative. If A is in this direction, it will be positive. Noor, H and A, hypotenuse and adjacent. So whenever you have a triangle with an angle, the opposite one is called this. This is called adjacent, and this is called a hypotenuse. I don't know what's it called in Arabic. Oh, some of your colleagues have already written it for you. المقابل O, adjacent is مجاور, and hypotenuse is وتر. Okay. The length is always positive. The magnitude of the length is always positive, but the direction could well be negative. Yeah. So this is what separates a vector from a scalar.
Scale.
Okay. So what happens is, say for example, this is in this direction. You are correct. This would still be positive, but then you will need to give it a negative direction. So say for example, a cosine theta is equal to 10 meters, for example. Okay. I will then need to give it a direction because it's downwards. I will need to say it is in the minus J direction. Don't worry about why am I using J. Where did the letter J come from? I'll come to it in a second, I promise. Okay, now we have two ways to express any vector. Okay, they are equally valid. They're just two different ways of writing it. One is to write it using the magnitude and the angle. So saying I have a vector of magnitude 10 meters at an angle of 45 degrees. Or I can use unit vector notation and write it down as something like 7.07 and 7.07. You might be wondering, what on earth am I doing here? The next slide will make it a bit clearer. What is a unit vector? Okay, a unit vector has a magnitude of 1 and has a very, very particular direction. AKA, we use that vector as a reference to compare all other vectors to. Okay, we have already used it in one way or another, but we haven't actually defined it. There's a reason why every time we talk about resolving, we either say resolve it into X and Y, or X and Z, or in the previous lecture, someone actually asked me, What if it's 3 dimensions, X, Y, and Z? Okay, why do we insist on projecting onto these 3 sort of thingies? Okay, and the answer is these are what we call a unit vector. Now, I will start by explaining unit vectors in terms of Cartesian coordinates, but later on, I will also explain to you an alternative method of describing vectors called polar coordinates. Okay, now we have 3 directions, X, Y, and Z. But since we already use X, Y, and Z for our coordinate system, X-axis, Y-axis, Z-axis, it starts to become a little bit cumbersome and also confusing if I use X for both the direction and the axes. So what we do is we choose 3 different letters to describe it. Okay, we say I, J, and K for X, Y, and Z. Okay, they're exactly the same directions of X, Y, and Z. We just use different letters to explain it, to name it. So instead of saying Vx equals 10 in the X direction, I write it as Vx equals 10 in the I direction. So I have different letters. Okay, how many people are having problems with choppy connections? Okay, I will tell you something to do that might be helpful. If you go to your Google Meet, click on these 3 dots in the corner. Okay, click on these 3 dots. Follow what my screen I'm doing in my screen. Click on these 3 dots and click on settings. Now and then click on video. And you will see it says send resolution and receive resolution. Now you're not sending, all of you have your cameras off, but for the receive resolution, click on standard definition, 1 video at a time. Choose this one. Standard definition, 1 video at a time. So what this does is, although I am actually recording and sending this video in HD, it will force your Google Meet to only receive it in SD. So hopefully it will require less internet and utilize less network. So hopefully this will reduce the choppiness. You don't have this window. I don't know. It might be in a different location. But for me, I click on these 3 dots here, and I click on settings. Yes, close your chat. Or if your chat is open, it will be around here. Okay. Going back to IJK. Now what we do is, when we write it in IJK notation or unit vector notation, we write it this way. Don't bother what these equations numbers are, okay? We write it as A equals the X component in the I direction and the Y component in the J direction. Same with B. We write B, the X component with the I direction, and B component with the J direction. And this actually gives us a very nice thing, because these AX, AY, BY, BX are just scalar components. They're just numbers. Okay? They're not vectors anymore. This is a vector. This A is a vector. But this AX and this AY are actually scalars. This direction bit is the one that changes it to a vector. Now there's something interesting here. These two say the exact same thing. If I say 10 in the I direction, meters, is the exact same thing. Actually, let me rewrite this. If I say 10 oops, what did I do? If I say 10 meters in the I direction, it's the exact same thing. Actually, let me do this. If I say minus 10 meters in the I direction, it's the exact same thing as saying 10 meters in the minus I direction. These two are exactly the same thing. Okay, so someone was asking me about positive and negative. This makes it really nice and really easy. Okay, so if I'm adding all the i's up, this plus and minus is really, really easy. So what do I do if I want to subtract two vectors? I simply subtract the components. If I want to know what is a minus b to give me d, I simply do ax minus bx, ay minus by, az minus bz, and then my vector d is simply dxi, dyj, dzk. Okay, it makes it really easy. I don't need to worry about angles or magnitudes or resultants. I don't need to worry about any of these things because I am simply adding scalars, because these numbers are actually scalars. Okay. Here's the PIQ. Which one of the following makes zero sense? No sense at all. Some say C, some say D.
D.
Okay, most of you say D. Now this one makes sense. What this one says is A equals 1 in the J direction. This is fine. This one also makes sense. It says 3i plus 1j minus 5j. This one is also okay. It tells us C is 1i minus 1j. Now D looks a bit weird because it has A. Okay, so most of you might think that it doesn't make actually any sense, but sorry. Okay, but what it actually does is it actually still makes sense, but it's in a very weird way. We don't write it this way. Okay, but technically it does make sense because what it tells us is the vector D is the vector A plus 1j. So the question is, what is vector A? If vector A, so say for example, vector A is 1i plus 2j. So then this is simply 1i plus 2j plus 1j, which is equal to 1i plus 3j. But we don't write it this way because it's just confusing. Is it correct mathematically? Yes, strictly speaking, it's not wrong. But do we do it this way? No one does it this way. Okay, so the actual answer is all of them make sense, but whoever wrote D is an idiot. Okay, so far we have spoken about adding and subtracting vectors. Now here's a question. Let's talk about IJK. We're going to stop talking about X, Y, Z for a bit. And I have this set of basis vectors, I, J, and K. And my question is, what is the relationship between I, J, and K? First, let's go back. What is the relationship between X, Y, and Z? What is the angle between X and Y, or between Y and Z, or between X and Z? 90. Perfect. Okay, they're at right angles. I, J, and K are also at right angles to each other. So the angle between I and J is 90, the angle between J and K is 90, and the angle between K and I is also 90 degrees. Perfect. What's the angle between just I and I? If two vectors are both I, what is the angle between them? 0. If two vectors are J and J, they're again 0. K and K, again 0. So far, this is really, really simple. And you might be thinking, okay, why are we even discussing this? Because these are going to actually become very, very important in a minute when we discuss how to multiply vectors. Okay, when we multiply vectors, there are two ways to multiply vectors. Okay, and this might sound weird because with normal numbers, with scalars, we only have one way to multiply numbers. 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, etc. There's no other weird way. But turns out with vectors, we can actually multiply them in two different ways. One, we call it scalar product or a dot product. And we call it that because when we use this multiplication, we actually write a dot between the numbers. And the other one is called a vector product or a cross product. And we call it because we use the multiplication sign across. So if I want to, if I want to say, I'll write it in words first. Actually, no, there is no writing it in words. If I want the scalar product of A and B, I will write C equals A dot B. If I want the cross product, I will write C equals A cross B. You might think I have forgotten to put the underline here, but I actually haven't, and you'll see that in a second. Okay, let's start with the scalar product. It's the nicer of the two. It's simpler. Okay. Let's take two vectors. A is AX, AY, AZ in the IJ direction and the IJK directions. B is BX, BY, BZ in the IJK directions. Now I want to do A dot B. A dot B is defined as AB cosine theta. Okay, or cosine phi, but I tend to like theta better. Okay. A dot B, this is a definition. This is something you need to remember. Okay. A dot B equals AB cosine theta. What is this A and what is this B? In the AB cosine theta on the right-hand side, these are the magnitudes of the vector. So actually, we should write it to be very, very clear. We should write it like this. Okay, mod A, mod B cosine theta. If we want to be very, very strict about how do we write it down. Okay. What do we do in it? What is a dot product? A dot product is the easier of the two products because it's actually exactly like normal multiplication for scalars. And the reason is we're actually multiplying the scalars of the two vectors. So A dot B, I'll just write it in full form, AXI, AYJ, AZK, dot BXI, BYJ, BZK. Now what do? I just start multiplying like I would do with normal multiplication, normal arithmetic, normal algebra. What am I going to get? AX BX plus AY plus AX BY plus AX BZ. Now I'm actually going to go to a whiteboard to do this. Okay, pay attention. A is equal to AX in the I direction plus AY in the J direction plus AZ in the K direction. B is equal to BX, BY, BZ, K, J, I. Okay, but now the question is, what is A dot B? I will write it in full again. AXI plus AYJ plus AZK dot BXI plus BYJ plus BZK. And now I'm going to actually multiply it out just like I would do for an absolutely normal multiplication in algebra. So help me out. If you have a pen and paper, do it with me. AX BX II plus AX BY IJ plus AX BZ IK. And then I will get the exact same thing for the Y and Z components. Okay, but in the second line, we'll have a bit different. Now, AY with BX would be J dot I. J and I, not I and I. Yeah? This will be J and J. This will be K and K. These will be different letters. So AY and BZ will be JK, AZ. BX is going to be KI, and AZ. BY is going to be KJ. I'll give you a second, write that down, and I'm going to tell you why do we do this very, very long thing and why is it important. A little bit ago, we defined what is I dot I. Yeah, we said I dot I equals 1. The angle between them is 0, and the cosine of them is equal to 1. Remember, we said the definition of the dot product of A dot B is equal to AB cosine theta. So if I do I dot I will get 1 times 1 times cosine the angle between them. Since both of them are on the I-axis, then it's 0. Cosine 0 is equal to 1. So my total result is 1. So what I get is, change the color. I dot I is 1. J dot J is 1. K dot K is 1. For the others, I dot J. What is the angle between I and J? We said 90 degrees. No, I and I is 0, but I and J is 90 degrees. So cosine 90 is 0, right? Which means that every single one of these has a cosine 90 in it. And so all of them go to 0. We only have 3 things left. The I dot I, the J dot J, and the K dot K. So an easier way to do it would be simply the easier way to do it would be AX with BX, AY with BY, and AZ with BZ. We don't need to do the others because we know in advance the result is always going to be 0. So our definition for the scalar product A dot B is AX BX, the I dot I just became 1, so just a scalar. So it's no longer a vector. AY BY is a number, AZ BZ is a number. None of them have directions anymore. And what do we do when we have just 3 numbers adding up without directions? It's just simple addition, no longer a vector addition. So the scalar product will actually give me just a number, a single number, a scalar number. This is why we call it a scalar product, because it takes 2 vectors and it gives us just a single number, a scalar. Now, because it gives us a scalar, okay, it has a very, very nice property that A dot P equals B dot A. There's no difference between the two. Okay, so A dot B is going to give me something, B dot A is going to give me the exact same thing. Okay, my second, my chat screen went away. And we're back. Okay. So far, so good. Any problems with the scalar product or what we've done so far? Okay, I'm going to assume that those who write yes mean everything is okay, and those who write no mean that no problem, because the other round is going to be painful. Okay. بعدنا تونا بادين نقول بسم الله. تونا نقول يا هادي تعال نتفاهم على الفيكتور برودكت. بعدين نقول بسنا. Okay. Next, the vector product. بنتغدى مع بعض بس خلينا نخلص الليكتشر. إنزين. The scalar product is what I call the nice product. The vector product is what I call the headache product because it's actually the more complicated one between the two versions. Okay. The vector product is the one where we use the x, which is what we normally use for multiplication. And the definition, the first definition of it is, okay, AB sine theta. So far, so good. The first one was AB cosine theta. This one is AB sine theta. So far, so good. No problems. Now here comes the headache. Which theta? Should I take the smaller theta or should I take the bigger theta? Either one is theta. Which angle do I take? The smaller one or the bigger one? Turns out the rule is we always use the smaller of the two angles. Okay. Whenever there's a chance to use two different angles for cross product, we use the smaller one. That's one. Now, the cross product is also called a vector product for a reason. Just like the scalar product was called a scalar product because the result was just a number, a scalar. The vector product is called a vector product because the result is actually a vector. So when we do A dot B, we get just a number. When we do A cross B, we actually get another vector as a result. And the direction of the resulting vector is at 90 degrees to both of the input vectors. Okay, so I need to see my own camera to make sure I'm doing this correctly. Rayan, I have no idea what the Astc rule. Can you tell me what the Astc rule is?
The first and second and third quadrant.
Perfect.
In the
Perfect. That is absolutely correct. So what happens is, if this is my first vector, and this is my second vector. This is my first vector. This is my second vector. They're at 90 degrees to each other, or whatever the angle is. Okay. My resultant of A cross B is actually going to be at 90 degrees to both of these. Okay. This is a rule. It has to be perpendicular to both of them. Now, if these have something like this, a bit of a weird angle, this still needs to be at 90 degrees somehow to both of them. So here's A cross B, and the result is A cross B in the up direction. And the way I do it is, I do it using what I call the right-hand rule. Now, there are many different ways. Your book, this is from a different book. They use a hand. Your book uses a different method. Your book uses a rather different approach for cross products. Where is it? This is what your book uses. I use an even different approach, which I like to think is to be a bit easier. 3 fingers. 1, 2, 3. Okay, you can think of it when you are speaking to your little brother or sister or cousin and you're trying to threaten them if they don't do something within a certain amount of time. What are they going to do? Okay, so when you are trying to threaten someone, especially a little child, what do? You go, واحد, اثنين. That's what we do. And this is exactly what we do in cross products. We go 1, 2, and then our resultant comes in our thumb. And this 1, 2, the order is very, very important. So 1 goes where the first vector is. 2 goes where the second vector is. So if this is my first vector, camera, this is my first vector, this is my second vector, my result is going to be up. What if I flip them? I do second times first. What? I don't understand.
I think this is a mistake, by mistake.
Oh, okay. Because this sounds like 2 people talking.
Yes, I think that.
Can you mute yourself, please? Okay, let me try to find who is it that is unmuted. I'm able to find who this person.
I think by mistake this is Dictor. Can you طلع?
I'm trying to find who the user is to mute them, but I have 160 people in this call. It takes a bit of time. Oh, okay. They've muted themselves.
Take lunch.
Zain. Okay. Apparently my camera also ran out of charge. So plan B. Going back to... Holy, this is bad. Okay, there we go. We still have about 6 minutes. Okay. So right hand. Okay. The rule is it has to be the right hand. 1, 2, 3. Now here's what happens. If I do this is 1 and this is 2, my 3 goes up. But what happens if I switch? Okay. If this is 1 and this is 2, then my result is actually down. So if I do I cross J, my result is going to be K upwards. If I do J cross I, my result is going to be downwards. Now I'm going to give you a very easy rule instead of going through all of these results. And I am going to give you this rule, and maybe we will end with today's lecture with this rule. Okay. You have three axes, I, J, and K. Okay. I'm going to write them one after each other. I'm just going to write them like an idiot. I, J, K, I, J, K, I, J, K. Okay. Now, the rule is, if I am going forward, my result is going to be plus. If I am going backwards, my result is going to be minus. So this is rule number 1. This is rule number 2. And rule number 3 is secant. It actually goes in a cyclic fashion. So what is I cross J? Plus K. I cross J is going to give me plus K. What is J cross K? Plus I. K cross I will give me plus J. What about the other way around? If I go J cross I will get minus K. If I go K cross J, I will get minus I, and so on and so forth. Someone's mic is on. Could you mute it, please? Okay. So going forward, positive. Going backward, negative. So far, so good? Have we understood so far the concept?
Yes.
Okay. A couple of people say yes. Some say no. Okay. The result of a vector product is another vector, which means it's not only a number, it also has a direction. Let me stop the screen sharing and then just get on the video, stop presenting. Okay, so the result of a cross product is a vector, which means it also has a direction. Okay. Now, how do we determine the direction of the vector? Now, each vector has components, I, J, and K. Okay. Whenever we multiply two unit vectors, we get a number, either 0 or 1. Now, we defined A dot B to be AB cosine theta, right? And we said that II is 0 degrees. And thus, if I have I dot I, it will be AB cosine 0. Cosine 0 is 1, so it's just going to be AB, right? So far, so good? Dot product is no problem? Okay. Now we also defined A cross B to be AB sine theta, right? Now sine has a different rule. sine 0 is actually 0, and sine 90 is equal to 1. Okay? So, and the result of this is also going to be a vector. So what is the direction of this vector? Is it up? Is it down? Is it in the I direction? Is it in the J direction? Is it in the K direction? So now we know the angle between I and J is 90 degrees. Correct? The angle between J and I is minus 90 degrees. So if I have a vector of I times a vector of J, my result is going to be plus K. And if I have J cross I will end up with minus K, because it's minus, because sine minus 90 is minus 1. Now someone asked, ليش سالب? Because when we asked the question, which angle do we take? We said theta is the smaller of the two angles between A and B. Okay. Now, if I have this, from here to here is plus 90 degrees. Now I have two options. Either I go plus 270 degrees, or I can go minus 90 degrees. Which one is smaller, 270 or 90? 90 is smaller.
90.
So I take minus 90 degrees instead of plus 270. Okay? So far, so good? Do we understand so far? Okay. Okay, I have one no so far. Okay, fine. So it's 1:20. We end our lecture here today. Tomorrow we go through the rules. Well, next lecture we go through the rules of I cross J, J cross I. When is it positive? When is it negative? We can either memorize a whole bunch of rules. When is it positive? When is it negative? Or we can find one simple rule that would tell us for all time when is what. When is it positive? When is it negative? Okay.
Doctor,
Yes.
I have a question. In the first PI question you gave us, can you open it? I don't understand some points.
Which one?
The drawing of what the answer is A cosine theta. I don't understand it. The graph of the first PI question, you open it for us in the beginning.
The first PI question. Okay, so that was the other slides. This one?
Yes.
Okay, what about it?
I don't understand it.
So we have a vector at a specific angle, and we want to know one of the components of the vector. Okay, so we have some vector A, and we want to find what is the y component of this vector. How do we find the y component of this vector? we are given this angle, theta. So we use trigonometry. We know that cosine theta is equal to adjacent over hypotenuse. Okay. Someone mentioned the names in Arabic. I don't know what it is.
Doctor.
Yes.
Doctor, this side is said to be opposite as the right. It is right angle.
Not quite. Tilt your head like this and look at this. Look at this. We're looking at this triangle.
يعني دكتور تو نفهم من كلامك بالمختصر المفيد ان المجاور للثيتا، الضلع المجاور للثيتا هو نفسه الاي واي، فاذا جبنا الضلع المجاور للثيتا يجي نفسه الاي واي.
صحيح. So whether I find this AY, this length, or this length, it's the exact same, isn't it?
اصلا الزاويه بتكون نفسها لانها على شكل زد.
That too.
Yes.
You have this rule.
نفسها
You also
بتكون
have one more rule in trigonometry which you can use. This is 90 degrees. So I can call phi equals 90 minus theta. So now I have three rules I can use.
يعني الضلع ده نفسه على طول.
Okay. So I can either do it using this triangle, or I can do it using this triangle. I can use this triangle where this is theta and this is 90 minus theta. You can do it any one of three rules, but the easiest rule to remember is you're trying to find the y component. So since this is a Z shape, whether you find this one or whether you find this one, it gives you the exact same result.
You mean like the two sides are parallel?
Yes, they are parallel.
Okay, thank you.
Yeah?
I got it now. Thank you.
Perfect. Any other questions? The lecture time is over, by the way, so anyone who wants to leave is free to do so.
Doctor, we can find this is lecture for YouTube?
Yes, I will upload it today.
For your يعني قناتك?
channel.
Yes, in my channel, but also the link is also going to be on Moodle. So if you open on Moodle, you can either go to Google, to YouTube and find my channel, and you will find all the lectures.
وش
Or
اسمها قناتك؟
you can go to Moodle, you just search for my name, Yahya Al-Saleh in English, or just search for FYS2101, our course code.
تمام دكتور مشكور.
Okay. Mariam, question 2 about sense. Which question 2? Also PI2? The one about okay, which one makes sense? Okay, got it. Where is this again? No. This one? Okay. So we are trying to find which one of these is wrong. Okay. The first one is fine. We have a vector which is only in the j direction. Okay. So if I draw an xy axis here or an ij axis, okay. The first one tells me I am a vector in the j direction. So this 1j. That's it. This is the vector. Does this make sense? Yeah, is it correct? There's no problem with it.
Yes.
The second one is a 3-dimensional vector, 3i plus 1j minus 5j. Okay, oh, sorry, it is a 2-dimensional, not 3-dimensional. So 3i plus 1 minus 5, so 3i minus 4j. So I'll go 1, 2, 3i minus 4j. It's going to be somewhere like this. Okay, so this is A, this is B. C is I minus j. So it's going to be here at 45 degrees. This is fine. D gives you another vector, A. Okay, so this vector in itself is made of ijk. Okay, so it's like saying D equals, what just happened? Why is it? Okay, it's like saying I have something I plus something j plus something k, okay, plus j. So it still makes sense. Okay, it's still correct. I can still do the math just like I did in B. I can do it in D. I can still do the mathematics. Okay, and figure out what is this vector. It's not wrong. It's just written in a weird way. So the correct answer is all of them make sense. All of them are correct. None of them are particularly wrong. Okay? Maria, let me see. I don't think we finished 2.4. Also, we haven't spoken about polar coordinates, which we touch on in this chapter a bit. Someone at the beginning of the lecture asked me, Annahu, this chapter in the book is very long and there's a lot of examples and a lot of math in it. If you understand everything we did in the lecture, you can simply do some of these examples in the book. Okay, and if you do these examples, then you are going to be absolutely fine. Okay. If you understand the lecture, you can try to do a few of these examples. If you manage to do them, you are perfect. You're good to go. Okay, your book has a lot of Khadra Zaide. 2.4, no. Maria, we did not finish 2.4 in all. So there's still a lot. So we finished the first part of 2.4, where there's the dot product, but we still have to do the second part of 2.4, where we are doing the cross products. So that part we haven't done yet. Someone was about to ask something?
Doctor?
Yeah?
Please upload the old slides you opened with us. The previous and the new and the whiteboard. Okay?
Yes. I uploaded it for last Tuesday. I've finished uploading it, but it hasn't shown to you yet. So today you will see Monday's lecture and today's lecture, inshallah. The whiteboard and the slides and the recording of the lecture.
I mean, you opened 2 different presentations. So you will upload the both?
Both of them. I actually, yes. I will put them all in one PDF and I will upload them there.
Thank you.
Okay, no worries.
Doctor,
Mm-hmm.
can you send the answer of understand your question?
I don't have the answers of understand your questions. There are no answers for these. So if you try to do specific problems and you have problems with them, bring them to the tutorial and we can take a look at them.
Okay, thank you.
Okay, because there's no solution manual. The questions at the end of the chapter, these questions, we have solutions for them, which I have uploaded on Moodle. But the understand your knowledge questions, we don't have solutions for these. So we have to figure them out while we're going.
Doctor, if it is fine if you send an email about quiz, what is included?
I will send an email with details about the quiz, what time is it going to be, and etc.
Okay,
Doctor?
thank you.
Okay. Rayan, yeah, sorry, someone was saying something?
Yes, doctor. in tutorial lecture, you will give us the question to solve them alone or together.
We will solve some questions together, okay? And then we will open the floor to your questions. So if you are, say, for example, you try to do some of the homework questions and you had a problem with some of them, you couldn't manage to get it to work. Okay, so in that case, you can ask about it in the lecture, okay, in the tutorial, say, because see, in the lecture, we don't have time to do as many problems as we would like. So what you could do is you can bring them to the tutorial there, and you can say, look, I tried to do this question, this question, this question, but I couldn't really figure it out. I had a problem with this bit, and then we can try to do them together in the tutorial. And it's for everyone's benefit. Ryan, office hours. So email me for office hours. I don't have standing office hours this semester, but if a student requests office hours, then I will arrange it on an ongoing basis. Okay. So the idea is most of the problems with solving questions will be solved in one way or another during the tutorials. And then problems that cannot be done in tutorials will be done in office hours. Or if there's another reason aside from problems, just email me. Okay, anything else, or shall we conclude this session? No? Okay, perfect. Have a good day and see you next lecture.